In question 4 of our stoichiometry series, we're asked, another component of acid rain is nitric acid, which forms when NO2, also a pollutant, reacts with oxygen and water according to the simplified equation. The generation of the electricity used in a medium-sized home produces about 16 kilograms of NO2 per year. Assuming that there is plenty of oxygen in H2O, what mass of HNO3 in kilograms can form from this amount of NO2 pollutant? Just like in all the other questions that we had, you first need to have a balanced chemical equation. And we do. This is perfectly balanced. In addition to that, I want to highlight what we know. We know that we have 16 kilograms of NO2, and we're looking for the mass of HNO3. So let's write these numbers down underneath. I'll start by writing down M for mass of NO2 is 16 kilograms. And right away we need to convert this number into grams. Reason for that is because the molar mass is recorded usually in grams per mole, so we need to be consistent. To go from 16 kilograms to grams, it's actually a simple conversion ratio. We take 16 kilograms and we multiply it by 1,000 grams per 1 kilogram. Notice that the kilogram units will cancel out, leaving us with only grams. 16 times 1,000 is 16,000. As mentioned, we need to find the molar mass now of NO2, and we can do that by locating the molar masses of each individual atom within one molecule of NO2. We have nitrogen, which has a molar mass of 14.00. We'll multiply that by 1 because there is a subscript of 1. There's only one nitrogen, plus 16.00 times 2 because there are 2 oxygens. Using our calculator, we have 14 times 1, which we don't need to do. Will just give us 14 plus 16 times 2. And this gives us 46. 46.00 grams per mole. I'll write that up here with the big letter M. 46.00 grams per mole. And using these two numbers, I can find the number of moles. And I can do that. I'll represent number of moles with N. I can do that by taking the mass of 16,000 grams and multiplying it by the flipped version of this. So I'll put 1 mole at the top and 46.00 grams at the bottom. Now, if you're not used to doing it this way, I do have on your screen a triangle which you can use to easily find your mass, moles, or molar mass. So I'll take 16,000 times 1 divided by 46. And this will give me 347.8. 347.8 moles. Keep in mind that at the very end, once we find the mass of HNO3, it should have 2 significant figures, because our number initially was 2 significant figures that we started with. I just found the number of moles, and I need to find the equivalent amount of moles of HNO3 by setting up a simple ratio. There are 4 NO2 molecules for every 4 HNO3 molecules. So we have to set up our ratio like this. 4 to 4. This column represents NO2 and this column represents HNO3. I'll write down the number 347.8 underneath this column, and X is what we're looking for, unknown. Since it's a 1-to-1 ratio, 4 to 4, 1 to 1, the number of moles of HNO3 will also be 347.8. So I'll write that down. I'll create a divider first. We have N is equal to 347.8 moles. What I have to do is find the molar mass of HNO3 and then multiply the molar mass by the number of moles here, and I'll end up with the mass. So let's go ahead and find the molar mass of HNO3. HNO3, we have 1 atom of hydrogen, 1.008 times 1, plus 14.00 times 1, only 1 nitrogen, and 3 oxygens. Calculator time, 1.008 plus 14 plus 16 times 3. This gives me 63.008. I'll write that over here. big M is equal to 63.008 grams per mole. Time to multiply this number with this number. Take a look at the triangle on your screen. You'll see what I mean. So I'll multiply this number by 347.8. And this gives me 21,914 grams of HNO3 produced. Our mass needs to be recorded in kilograms according to the question, so I'll divide this number before even writing it down by 1,000, and I get 21.9. Now, since we want two significant figures, 21.9 kilograms. Since we want two significant figures, this 9 will influence this number because it's greater than 5. Our real mass is 22 kilograms. And there you have it. That is how to solve stoichiometry problems.